Hi guys, this video might be running a little late, but most of you are taking or doing case testing right now, so I don't feel too bad about it. I'll make this due tomorrow at 2 o'clock to give you all plenty of time to watch this. I think at the beginning of the school year, I promised y'all 24 hours, so I'll still honor that. We're reaching something I've been kind of dreading because I remember when I first learned computer science, I hated it, and I hated my instructor, and I hated computers, and I hated life. So you all will probably feel the same way. This is recursion. I know a lot of you have had higher maths, so you all probably dabbled a little in recursion. Recursion is just a function that calls upon itself over and over until a task is completed. All right, I'm going to start out with a real simple one. Then I'm going to start out with a simple, supposedly simple math one, but still they're kind of a little bit hard to wrap your head around. If you're somebody that watches these videos and just casually does other things, I think you need to put that on pause for just a little bit. This is something you need to concentrate on what's going on. All right, I've just got a simple program right here. It's basically a program that's going to call upon a message recursively. All right, let's look at the main is just actually it's just two words, two lines, 2 words long. Int main, it's going to call message. Then after it's done, it's going to recursively call message, and after that, it's going to return 0. All right, so let's look down at message. All right, you're going to send along with your message a number, an integer, and I'm just for this program going to use the number 3. All right, I'm going to send message number 3. Then it's going to see out message call with 3 in times. So my the times is basically the variable. All right, if times is greater than 0, it's going to see out this is a recursive function. Then it's going to call message, the function, with times minus 1. So if I start out with 3, all right, this is going to see out message called with 3 in times. 3 is greater than 0. It's going to see out this is a recursive function. Then it's going to call on message again with times, which is 3 minus 1. So it's going to be message 2. It's going to call on this function again, message 2. Then it's going to go through it, and it's going to be message called with 2 in times. 2 is greater than 0. Then it's going to see out this is a recursive function. Then message 2 minus 1. So it's going to be message 1. It's going to start over again. See what this keeps calling on itself? This keeps decrementing the number, and it keeps calling on itself. So you can figure out when this gets down to 0, it's going to be done. So let's go ahead and run this, and you can see. Message called with 3 in times. This is a recursive function. Then it was called again with 2 in times because we decremented it. Then it was called with 1 in time because we decremented. Then it's finally 0, and then it kicks out. All right, that's not too bad. All right, that's the front end of a recursion, a recursive function. There's a part that's a little harder to understand, which I'm going to show you now. Everything that function did was correct, but there's also coming out of the recursive function. And I think this might simplify this a little bit. This and the video I've got coming up on a math principle. All right. So I'm going to run this first. I'm going to just go straight into running it. It's the same thing up until here. Message called with 0 in times. All right. This is the back end of recursion. All right. Recursion keeps calling on itself. All right. But there's a certain amount of memory that goes along with this. So I want you to just look at this message returning 0 in times, message returning with 1 in times, message returning with 2 in times, message returning with 3 in times. Right? All I did was add these 2 lines. What happens is this counts down. We started out with 3, 2, 1, 0. All right, and it kept doing these messages. But what happened was every time it called this function, before it was just doing up to here. Now there's something after this if statement. Once this if statement has exhausted itself, it's supposed to go on to the next line. So the first time through, this is going to be the first time it makes it down here, it's going to be times is a 0. All right, because times, when it's greater than 0, it does this. Well, eventually when it's 0, time is 0, it'll pass by this and do this. All right, coming out of recursion, we have to do all the things that was in memory. It's called the program puts it in pause for a second, and this will make more sense on the next video. But now this is going to return with a 0, okay? And then it's going to go back in memory and know that it did this with a 1 and a 2 and a 3. That's all I did it with, is in a 3, okay? Because it's got to go back and finish off its recursion. When we did this before, I had these highlighted out. These never had to happen. Now they do. This is like a nested loop. If you did anything in Excel, working on the inside, then working out in nested loops. So let's run this again. All right, 3, 2, 1, 0. All right, it goes all the way down to 0, and it's did the front end of that function. Now it comes back out of the function, right? And it goes back, the rest of the function has to run with 0, 1, 2, 3, and print it out. That's what this does. That's what recursion does. It wasn't just calling on this. In the first when I first ran this, all it was doing was this. You weren't seeing this, but in essence, the program was doing it. This just makes it obvious that coming back out of the function, it has to take into consideration everything that's built up to it. All right. It's got to take into consideration the message 0, message 1, message 2, message 3 in its entirety. All right, so just let that sink in just a little bit. I mean, if your mind just totally rejects these last 4 lines, maybe it'll make a little more sense with this recursive function of factorial. Let me run this. All right, you guys have probably had this in a higher math. Matter of fact, I think they even teach this in algebra anymore. Factorial is 4 factorial is 1 times 2 times 3 times 4. 3 factorial is 1 times 2 times 3 times, that's it. Okay. Mathematically, it looks like this. N factorial equals n times n minus 1 times n minus 2 times n minus 3 and so forth. For as many n's as you have. All right, so this is a recursive program we're just gonna enter a number, right? I'm gonna enter a smaller number. I'm gonna enter 4, and it's gonna calculate what recursion, what recursive 4 factorial is. This program will do any up until you exceed the C++ number of digits for an integer. This will do as much as you want, but we're only going to run this to 4 because I want to explain it as we go along. All right, so I'm going to type in 4. That's going to be my number 4. Enter an integer value, and I will display its factorial. So I'm going to enter 4 here. All right. The factorial of 4 is factorial number. So it's going to be factorial number. I'm going to call on this factorial with the number 4. Let's go down and look at the actual function. So here's the function. I put in a 4. Okay. If it would have been a 0, I'm going to return 1. Else, I'm going to return n times factorial n minus 1. So the first time through this is going to be n times factorial n minus 1. It's going to be 3. Okay. And it's just going to go all the way through that until it goes down to 0. I'm going to go ahead and run the program just to show you that it works. So an integer value, I will display its factorial. Factorial of 4 is 24. I'll run this again. I can run this as a much bigger number. Let's say 13. You can see how this just blows up really fast. So the factorial of 13 is, looks like, actually I can't count. 193 million. Nope. Let's see. 1,932,000,000. So it blows up pretty fast. So by entering n, I loop through this. Now let's look down here in the comments. I kind of tried to make this a little bit more understandable. All right. So if I enter 4, I make it f4, which is factorial 4. Factorial 4. And you can see from the function n minus, that turns it into n times factorial n minus 1. So factorial 4 equals 4 times f3. All right. I tried to explain this in the last one. It's a hard thing to explain. I never thought my instructors did a good job, and I really doubt that you all think I do a good job explaining this. It's a complicated thing to explain. But then it puts this function on pause. All right. And then it sends f3. It sends a 3 to the factorial function, the factorial function. Okay. Then that becomes 3 times factorial 2. It puts it on pause. Okay. Now we're going to send it a 2. That makes it 2 times f1. And it puts that function on pause. Sends it to f1. All right. That becomes 1 times f0. It puts that one on pause. Then when you get to f0, that's our special case. All right. If n equals 0, we return 1. That's our base case. All right. This is our recursive case. So this is our base. All right. We've ran through this. And in the last video, I said the rebound coming out of the recursion. Okay. We've got this 1 and these 4 paused functions. All right. Watch how this works. All right. F0 is 1. All right. So coming out of this, I make F0 1. Right. And it no longer is pausing. It's actually recursive. All right. So 1 times 1. So F1 is 1 times 1. It's 1. Right. So I put it here. And this goes to recursion. It's no longer being paused. F2 equals 2 times 1. All right. Which is 2. I go here. And the way this program's written, now it goes from pause to recursion. Right? And then you all can see what's happened here. F3 is 3 times 2. This becomes 6. Right? This is no longer paused. And this becomes recursion. and that's your final answer, equals 24. That's what this program here does. All right. The hard part to understand and the hard part to realize, and you have to write a few programs and copy a few programs and whatever you have to do to get through it, is to wrap your head around this just doesn't count down, because this, if I would have put 5 in here, it would have went 5, 4, 3, 2, 1, 0. Okay, nothing would have happened. It's the rebound out when things actually happen. When your program has exhausted itself is when the recursion really starts. My recursion was bottom up. You can see I worked through this program down 5, 4, 3, 2, 1, sort of like I did in the first video. And then the recursion starts once I get my base case and I work my way out of it coming back up. There's no test on this coming in the next week or two. This will be part of the final exam. There's probably going to be a little bit of a program on this. I will take it easy, but recursion is not going away. Recursion is something you use in higher math, especially those of you that have had some calculus, probably even pre-calculus, has had at least some recursion. So, I mean, it's a concept that's used in higher level math and used a lot in higher level computer programming. All right. I would strongly suggest you watch this video again if you didn't understand. If you come to me, maybe I can explain it. Even if you're a little bit confused about it, come to me. I can explain it maybe a little bit better. There's lots of videos on this online. Maybe somebody else explaining it. Like I said, my instructors, I thought, butchered this. So I actually give this a lot of thought with this thing here to try to explain it to you. Okay. It's nothing to trace the code down, tracing it from here down. It's to understand coming out of the bottom, the base case, all the way up. The recursion is on the way back up. It's not on the way down. All right. So I'm going to find some other videos, and I'm going to try to find some readings. I haven't had y'all do much reading. I haven't had y'all do any reading this semester or this year. So just so that we've got this down. All right, guys, I will see you on, you all might be in my class when you're all watching this video, but I will see you on Wednesday. Have a good rest of the day.